Hi viewers, this is Dr. Gunamani Jana and you are watching video with me on Java. In this video, we will be going for the basic concept of Java and also the object oriented analysis and design concept. If you see this Java, it is a class based object oriented programming language that is intended to let application developers write once and run anywhere. That is the ORA. Write once, WO, and run anywhere. It's meaning that once this Java program is compiled, it can run on all platforms that support Java without the need of recompilation. Java is known for its simplicity, robustness, and security features, making it popular choice for enterprise level applications. And also, it helps to create a reusable code and modular programming. If you see the most popular language across the globe, you find around 22.42 percentage people in the globe they use Java. Similarly, 21.01 percentage they use Python. Like that, we can see JavaScript 14 point something and C++ 9, SQL 5, PHP 5.16, MATLAB 4.7, Node.js 4.44, TypeScript 3.28, C Sharp 2.51, Kotlin 1.61, and also Go language that is 1.44%. So from this chart we can clearly understand around 22, that is the maximum percentage of the software developer they prefer Java as a developing language. Now coming to the key features of Java, Java is platform independent. The meaning of this platform independent that once the Java program it is compiled, it converts the source code to a bytecode and the Java virtual machine executes this bytecode and run this program. This bytecode can run on any platform, so let it be the Windows, the Linux, or the Mac operating system, which means that if we compile a program on Windows, then we can run it on Linux or the vice versa. So each operating system has different Java virtual machine, but the output produced by all the operating system is the same after the execution of this bytecode. So during compiling, we convert the source code to bytecode, and this JVM runs this bytecode for the execution. That is the reason Java is called a platform independent language. Then the second feature is object oriented programming. Java is an object oriented language promoting the use of objects and classes. Organizing the program in the terms of a collection of objects, that is in a way of object oriented programming, each of which represents an instance of this class. There are four main concepts of this object oriented programming. So we'll discuss one by one. First one is the abstraction. Abstraction in Java, it is the process in which we only show essential details functionality to the user. The non-essential implementations details are not displayed to the user. In Java, abstraction is achieved by interfaces and also abstract classes, and we can achieve 100% abstraction using the interfaces only. Then data abstraction may also be defined as the process of identifying only the required characteristics of an object, ignoring the irrelevant details. And the properties and behaviors of the object differentiate it from other object of similar type and also help in classifying or grouping the object. Then we see the difference between the Java abstract classes and the Java abstract methods. An abstract class is a class that is declared with the abstract keyword. So we have to declare with the abstract keyword. An abstract method, it is a method that is declared without implementation. So this is the difference between the abstract class and abstract method. An abstract class may or may not have all abstract methods, and some of them can be concrete methods also. A method defined abstract must always be redefined in the subclasses, thus making overriding and compulsory or making the subclasses itself abstract. Any class that contains one or more abstract methods must also be declared with an abstract keyword. So these are the points to remember. And there can be no object of an abstract class. That is, an abstract class cannot be directly instantiated with the new operator. An abstract class can have parameterized constructors, and the default constructor is always present in the abstract class. So if you see the next one is the interface. Interfaces are another method of implementing abstraction in Java. And the key difference is that by using interfaces, we can achieve 100% abstraction in Java classes. In Java or any other languages, interfaces includes both methods and the variables, but lack a method body. Apart from abstractions, interfaces can also be used to implement interfaces in Java. Then, if you see the advantages of abstraction, there are a number of advantages. First is it reduces the complexity of viewing things, then it avoids code duplication and also increases reusability, helps to increase the security of an applications or program as only essential details are provided to the user. It improves the maintainability of the application. It improves the modularity of that application also. In the disadvantages, few disadvantages are also there. Abstraction can make it more difficult to understand and how the system works. It can lead to increased complexity, especially if not used properly. This may limit the flexibility of the implementation. So these are some of the disadvantages. The second point is the encapsulation. Encapsulation in Java, it is a fundamental concept in object-oriented programming that refers to the bundling of data and methods that operate on the data. That means your method operate on the data. So that is within a single unit, we call it as a class in Java. And Java encapsulation is a way of hiding the implementation details of a class from outside access, and only exposing a public interfaces that can be used to interact with the classes. Now in Java, encapsulation is achieved by declaring the instance variable of the class as private. So you try to understand the variable, we declare it as a private, which means they can only be accessed within the class. To allow outside access to the instance variable, public methods called getter and setters are defined, which are used to retrieve and modify the values of the instance variables and respectively. By using getters and setters, the class can enforce its own data validation rules and also ensures that it, its internal state remains consistent. Right? Then the encapsulation. In this encapsulation, it is defined as the wrapping up of data under a single unit, and it is the mechanism that binds together code and the data it manipulates. Another way to think about encapsulation is that it is protected shield that prevents the data from being accessed by the code outside the shield. Technically, an encapsulation in encapsulation, the variables or data of a class is hidden from any other classes and can be accessed only through any member function of its class in that declared. So as in encapsulation, the data in a class hidden from other classes using the data hiding concept, which is achieved by making the members of methods of class private. And the class is exposed to the end user or the world without providing any details behind the implementations using the abstraction concept. So it is known as combination of data hiding and abstraction. So this encapsulation can be achieved by declaring the variable in the class as private and writing public methods that I already discussed, and it is more defined with the setter and getter methods. Then what are the advantages of the encapsulation? First one is the data hiding. It is a way of restricting the access of our data members by hiding the implementation details. And encapsulations also provides a way for data hiding, and the user will have no idea about the inner implementation of the class. It will not be visible to the user how the classes is storing values in the variables. The user only know that we are passing the values to a setter method and variables are getting initialized with that value. Then the second one is the increased flexibility. We can make the variables of the class read only or write only depending on our requirement. So for like that we can use the method set name, set age, like that we can do. And also we have to omit the get method like get name, get age from the above program. Then the reusability encapsulation also improves the reusability and is easy to change with new requirements. Testing code is also easy and freedom to programmer in implementing the details of the system. So these are the some of the advantages. If you see the disadvantages, it can lead to increased complexity, especially if it is not used properly. Second one, it can make it more difficult to understand how the system works and may limit the flexibility of the implementations. Okay, these are the disadvantages. We see a template here. So we define the class as class name. So as I told you that the variable age and data type is integer. So we use private integer age using the getter method. So use the method is public integer get age. So it return the age. In the set method public void set age integer age this dot age is equal to age. Okay, now let us see one program, actual program implementation. So you define a class with name rit1 and here public static void main string arguments the main function it is the public and the name n1 which is equal to new name we created things like n1. So n1 dot set age 19 system.out.println the age of the person is n1 dot get age, so we can get the output as 19 here. You can clearly understand. Then the concept is inheritance, one of the property of the object oriented concept. Java inheritance is an important pillar of OOP. It is the mechanism in Java by which one class is allowed to inherit the features, field and methods of another class. In Java, inheritance means creating new classes based on existing ones. So that's why a class that inherits from another classes can reuse the methods and fields of that class. In addition, we can add new field and you get it now. So what is the existing that inherits and you can also add any methods and field and methods you can add. Why do you need Java inheritance? So first thing is the code reusability, second one is the method overriding, third one is the abstraction. So code reusability you can clearly understand because you are inheriting some property there, no need to create it again. What is the additional things we can put it there. And the method overriding is achieved only through inheritance. It is one of the ways by which Java achieves runtime polymorphism. Then is the abstraction. The concept of abstraction where we do not have to provide all the details is achieved through inheritance. So all the implementation is done using this inheritance. Okay. Then important terminology used in the Java inheritance. One is the class. You know, a class is a set of objects which share common characteristics or behavior and common properties or attributes. Okay. So class is not a real world entity. It is just a template or blueprint, a prototype from which objects are created. Then the superclass or the parent classes. The class whose features are inherited, we call it as a superclass or the parent classes. Subclasses are the child classes. The class that inherits other classes is known as the subclass or the child class. The reusability, inheritance supports the concept of reusability. So these are some of the important terminology. Then we go for the another object oriented concept that is the polymorphism. Polymorphism allows us to perform single action in different ways. In other words, polymorphism allow you to define one interface and have multiple implementations. Poly means, as you know, it is many, and morph means form. So we have a different type of polymorphism in Java. Mainly, we are having two type of polymorphism. One is the compile time polymorphism. Second one the runtime polymorphism. So first to discuss about the compile time polymorphism. It is also known as the static polymorphism. Okay. So this Java does not support the operator overloading, but it go for the function overloading. Okay, two things are there. One is the function overloading and also operator overloading, but Java does not support the operator overloading. So we discuss about the function overloading or the method overloading. When there are multiple functions with the same name but different parameters, so this is we call it the function is overloaded. Okay, so this is the concept of method overloading. Then what is this function overloading? It is a feature in C++ where multiple functions can have the same name but with different parameters lists, and the compiler will decide which functions to call based on the numbers and the type of arguments passes to the functions. We see the example there we can understand. Then operator overloading, this is also a feature of C++, where the operators like plus, minus, multiplication, etc. can be given additional meanings when applied to user-defined data types. Then in the template, this is also a powerful feature in C++. Then this is the things we talked about, the static, and then we go for the runtime polymorphism. It is also known as the dynamic method dispatch. It is a process in which a function called to the overridden methods is resolved at runtime. And this type of polymorphism is achieved by method overriding. And in method overriding, on the other hand, it occurs when the derived classes has a definitions for one of the member functions of the base class. That base function is known as the overridden. Now, let us see the subtype or runtime polymorphism. First one is the virtual functions. It allows an object of a derived class to behave as if it were an object of the base class. And the derived class can override the virtual functions of the base class, provide its own implementations, and the function call is resolved at runtime depending on the actual type of the object. Then, if you see the polymorphism from the diagram, you can understand the polymorphism is divided into basically two. One is the compiler time, second one is the runtime. And the compiler time is divided into two. One is the function overloading and operator overloading. And Java is not supporting operator overloading. It is only going for the function overloading. The second one is the virtual function under the runtime. Then some of the advantages: increases code reusability, okay, and improves readability and maintainability, supports dynamic binding, enabling the correct method to be called at runtime, then enables subject to be treated as a single type, making it easier to write generic codes that can handle objects at different types. Then some disadvantages: it can make more difficult to understand the behavior, especially if the code is complex. And this may lead to performance issues as polymorphism behavior may require additional computations at runtime. Then other things are that the simplicity. Java syntax is simple and easy to learn, and especially for those who are familiar with the C++, it eliminates complex features like pointers and multiple inheritance. Okay, so these are the things there. So making it easier to write the program, debug it, and maintain code. Robustness. Java language is robust, which means it is reliable. So it is developed in such a way that it puts a lot of effort into checking errors as early as possible. So okay, so these are the some of the concept. Then the security, as you know, in Java we don't have pointers, so we cannot access out of bound arrays. Then the distributed, we can create distributed applications using the Java programming languages, RMI, remote method invocation, all the enterprise Javins, all things we can use. Then multi-threading, Java supports multi-threading, enabling the concurrent executions that is used in games and real-time simulations. Then portability, as you know that Java code written on one machine can run on any another machines. So this is called the platform independence or the concept ORA, write once and run anytime. So this helps in portability. Then high performance Java architecture is defined in such a way that it reduces the overhead during the runtime. So it uses the compiler JIT, just in time compiler, where the compiler compiles code on demand basis, where it only compiles those methods that are called, making applications faster. What is not called, it does not compile that one. If you want, then how Java code is executed, that you see it here from this diagram, you can clearly understand that we write a program with a name hello world.java. Then the Java compiler compiles it, it converted to the hello world.class. Then the JVM machine run it and convert the bytecode, it executes and we get the output. Then how the Java code executed, that you see it here. For writing a program or creating a program, Java programs are written using the text editor or the IDE, integrated development environment, like IntelliJ, IDEA, Eclipse, or NetBeans. The source code is saved with extension .java, file.java, right? Compiling, so use the Java compiler. So suppose the name is program1.java, then we at the command prompt we write it Java C space program1.java. So it compiles if everything is correct. Then we run it using the command Java space the file name program1, right? Then and the diagram you can clearly understand. The on the top of the hardware, we are having the Java program, that is the interpreter is there and Java API is there and Java virtual machine is there. On the top of that, Java program runs, right? Then coming to the running of the program, the JVM, actually Java virtual machine, it executes the bytecode, execute the bytecode into the machine code, and the program is run. So let us write the first program in Java. So this is the file name. You can put it at hello world.java, and I define the class public class hello world, and public static void main string argument. The main function starts here, and we go for a statement like system.out.println hello world. So if you run this program, then we first compile in the command prompt java c space hello world dot java, and once it is compiled, if it is error free, then we go for running this program java space hello world. Okay, this is the way we can write. Then before learning this Java, we must have some idea about the Java virtual machine. The JVM is an integral part of the Java platform. It is responsible for execution of the bytecode. That you know. Writing a program is done by a Java program like you and me, whatever thing, and the compiler is done with the Java C compiler, which is included in the JDK program, Java Development Kit. It takes the Java program as input and generate the bytecode. In the runtime running phase, the JVM executes the bytecode. So this is how it is done. Okay. Now you understand that the function of Java Virtual Machine is to execute the bytecode to produce, which is produced by the compiler. And every operating system has a different JVM, but the output they produce after the execution of the bytecode, it runs in all the platform. That's why it's called platform independent, right? Then coming to the bytecode is an intermediate representation of the Java code. It is generated by the Java compiler. It is a platform independent and can be executed by JVM. Bytecode is platform independent. It is not depending on a platform. Then JDK or Java Development Kit. While we are using the term JDK, when we learn about bytecode in JVM, so as the name suggests, it is complete Java Development Kit or JDK. That includes everything, including the compiler, Java runtime error, JRE, Java debugger, Java docs, etc. All. And for this program to execute in Java, we need to install JDK in our computer in order to create, compile, and run the Java program. Then coming the JRE, this JDK includes the JRE, that is the Java runtime environment, and JRE installations on our computers allows the Java program to run. However, we cannot compile it. JRE includes browser, JVM, applet support, and plugins. For running the Java program, a computer needs JRE. Then the garbage collector in Java program. In Java, programmers cannot delete the object. To delete or recollect that memory, JVM has a program called the garbage collector. Garbage collector can recollect the objects that are not referenced. So Java makes the life of a programmer easy by handling memory management. However, programmers should be careful about their code whether they are using objects that have been used for a long time, because garbage cannot recover the memory of objects being referenced. Then class path. The class path is a file path where the Java runtime and Java compiler look for .class files to load. By default, JDK provides many libraries, and if we want to include external libraries, they should be added to the class path. Basically, everything in the Java represents. Okay, this is the main function. Then coming to the bytecode, as I discussed, it is a non-runnable code. After it is translated by the interpreter into a machine code, then only it is understandable by the machine. It is compiled to run on JVM. Any system having JVM can run it, irrespective of their operating systems. That's why Java is platform independent, and bytecode is referred to as the portable code. Then machine code. Machine code is a set of instructions that is directly machine understandable, and it is processed by the central processing unit. It is just the 0 and 1 machine code, whatever you say. So if you see the difference between the bytecode and machine code, bytecode consists of binary, hexadecimal, macro instruction like new, add, swap, etc. which the CPU cannot understand directly. But the machine code directly it consisting of the binary number 0 and 1, which the machine can understand, CPU can understand. Byte code is considered as the intermediate level code, machine code is considered as the low level code. Then byte code is a non-learnable code, okay? But machine code is a set of instruction which the CPU can run. Byte code is executed by the virtual machine, JVM. The machine code is not executed by the virtual machine, it is directly executed by the CPU. So these are some of the things. What is the advantage of Java? As I already discussed, the platform independent, then the object oriented security, layers community is there to support you, and enterprise level application also you can develop and execute. Disadvantage, the performance Java can be slower compared to other programming language like C++ due to its use in virtual machine, because JVM is there an extra unit, that's why it become a little slow. Memory management, Java's automatically memory management can lead to slower performance and increase the memory usage. Then this is all about the things, and the next video will be going for the programming, how to program in Java, what is the software you need to install, and all things. Okay. Thank you for watching this video. If you have any queries, do drop a mail in my email ID drjijan@gmail.com. And if you like this video, please do share with your friends, and also don't forget to subscribe this video. Thank you all for watching this.